Hello, Hannah. Hey, Jesselyn. Is that how you say your name? All right. As we as we get rolling, um, what did I say in that email to you? Everyone has all the paperwork for notes and homework. We'll have to get that to you ASAP. Until then, you know, somehow we'll manage. You don't happen to have a printer at home, do you, Jesselyn? Oh, okay. So maybe for like a day or two here, we can have you use the printer, and I'll just kind of send you the papers that we would like need today and tomorrow or something. So all right, Dakaya is here. Connor, Aaron. Well, considering the time, uh, let's get rocking here, people. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, so really quick before we bang out some quick and easy notes. Um, let's see. Last week we started off with like section 2.2, right? And actually, I should probably present my screen. So Zach, I almost forgot here. Zach, can you see my Google Classroom paper, or not my paper? Okay. All right. So everybody, just kind of recapping last week. We did 2.2. Which 6 people. So there still might be a few of you that need to do. That was due the 24th. 2.2 notes and 2.2 homework. And then 2.3. Those have also been due. Only a couple people. So this always interests me. What comes first is the notes. Couple people have given me the notes, but more people have given me the homework. So it's a little weird. It's not like it's super insane or anything, but that's a little weird. And just another reminder for like the 50th time, if you don't want to lose points, that there's really no reason for you to lose points. I mean, don't turn in stuff late. Now, I want to emphasize this quiz. So there was a quiz I posted on Thursday. It's pretty quick and easy, I think. It's on a Google Doc. That's technically due tonight. Remember, these quizzes are important. Now, Jesselyn, you don't have to do this. So anything before today, Jesselyn, you don't really have to do. So just kind of keep that in mind. But for these, 8 or 9 people, well, actually, yeah, no, 12 other people, 11 or 12 other people. You need, I would highly, highly, highly recommend you do this ASAP. You don't want to lose points because you turned it in late on something like a quiz, and then kind of other stuff. But, let's get down to business today. We have 2.5. So get this paper out. It shouldn't really take us that long to do it. So get out 2.5 really quick as I double check. So 2.5, Jack is here. Better late than never, right, Jack? So, okay, here we go. All right. So, this paper starts out with talking about we were recently focusing on problems like this. Okay? So, Jack, how would we do this one? This is like from basically last week or something. Jack, what do I got to do here to pretty much like simplify number 1 here?
You distribute 5.
That's right. Because we can't really do what's in the bubble here. Like normally, if you were thinking about PEMDAS, you would think, oh, let's do what's in parentheses. But you can't do 2n plus 3. They're not like terms. So we are able, though, to multiply 5 and, like Jack said, distribute through here. So 5 times 2n is 10n, and then 5 times positive 3 is positive 15. Same thing here. We would, since we can't do what's in parentheses, x minus 7, we can't really do anything with. But we can multiply negative 2 to both of these terms inside the parentheses. So, because again, it's like this negative 2 is being multiplied to this whole quantity of x minus 7. So negative 2 times x is just negative 2x. Nothing really to do there but put them together. And then negative 2 times negative 7 is positive 14. And that's all you can do there. Okay? And we were also doing stuff like this from last week. Aaron, if you want to unmute here. How would we do a problem like this where it's like x to that power times x to that power?
Add the exponents.
Very good. And that will get you, so you write down the x first of all. Some people forget that, or at least they forget to say it. I'm not saying that's what Aaron just did. I'm thinking more like a lot of students I've had in the past. So yeah, you write down the x again, but then yeah, Aaron's right. You would add these powers. That's a shortcut. So negative 3 plus 8. Use your calculator if you're not sure, because it's a negative 3 and a positive 8. That gets you positive 5. Correct me if I'm wrong. I'm doing that in my head. And that's the answer. That's the simplified answer. So you have to know when you can bust out this shortcut of adding the powers. One final, this gets a little bit juicy, I suppose. So Connor, what would you want to do here to see? All this is like this monomial. Technically, you could call this a monomial of 4xy to the second power. And this other thing in the bubble, you could also sort of call a monomial, because it's just like one term, 6x to the third, y to the seventh z. And it looks like we want to multiply them together. So Connor, what say you? Like anything we can do here?
You add the exponents, and then you just multiply the numbers.
Which numbers? I know you know what you're talking about, but
just 4 and 6.
Yeah, there you go. That's pretty like well said. So we can like what Connor's looking at, he's like all of this is being multiplied together. So you can almost like pick and choose what gets multiplied together. Like, yeah, there's technically a multiplication sign there in a way, but there's multiplication everywhere. It's like 4 times x times y squared times 6 times x to the third. All this is being multiplied together. So we can almost like put the things together that can actually simplify. So Connor is saying the 4 times 6, that's just like second grade. Ooh, did I do that right? Yeah. That's like second grade multiplication. That's a regular 4 and a regular 6. So those multiply together to make 24. But then from there, you have to do like x times x to the third. Okay? Hannah, do you know what that's going to be when you do x times x to the third, how that simplifies? Hannah, is your microphone working, Hannah? You might need to unmute. Would it be 3x? You're like yes and no. Technically, you wouldn't say 3x. No. You wouldn't even say x to the third because that already is x to the third, and technically, that is x to the first. So when you do x, which is technically x to the first times x to the third, it would be x to the fourth. Okay? And then y to the second times y to the seventh. That's where you add the powers and get y to the ninth. And then you have this z, which is technically z to the first. But there's no other z's to multiply this with. Like this monomial didn't have any z's. So it's really just, z or z to the first. So this is the answer for number 4. Okay, people? Hopefully that helped as like a review, after the long weekend. So what we're doing today in section 2.5 is we're continuing to multiply. Don't be confused by all this nonsense. I probably should have just erased it completely because in whatever textbook we have, like it might say multiplying and factoring, but we're not going to factor yet. I think we're going to save all the factoring, I think we're going to take a test on all the multiplying, and all the simplifying, and we're going to wait to do all the factoring until like after we've taken a test on like maybe the first part of chapter 2. So we're just going to keep on multiplying, and it's like in this section we're going to see if you can combine the skills of all this stuff. So in other words, when you look at this, I don't know, Dakaya, what property that starts with a D? What property comes into your mind when you look at this example, Dakaya? Like, what do you want to do here, basically? What's that? Divide? No, maybe not that D word. Distribute. Very good. Kind of like Jack said earlier. See up here, this was distributive property, this was distributive property. Might have been a little more basic, We're just taking it a little bit to the next level. Like now we're distributing a negative 3x squared. Oh no, But it still needs to be the distributive property because we're multiplying this negative 3x to the second times this entire bubble, And obviously, how many terms are here, Zach? Like how many terms are in this bubble? Yeah, like if you consider this polynomial like in this bubble, 4x cubed plus x squared minus 6x minus 7, if you consider this like just a polynomial, how many terms in this polynomial?
4.
Yeah, 4. Just like, again, I'm over-explaining it a little bit, but I want to review a couple vocabulary words. Like this out here, this negative 3x squared, you could technically describe it as a polynomial, but it's only got one term. So you could describe this as like two polynomials being multiplied together. But you could be like a little more specific and say, oh, this is a monomial times a polynomial that has 4 terms. Either way, again, I'm over-explaining that a little bit. But bottom line is we're going to need to distribute. So here we go. We have to combine all this stuff. So when we do negative 3x squared times 4x to the third, we do negative 3 times 4 for negative 12, and then we can do x to the second times x to the third to get x to the fifth. I hope that makes sense to everybody, like doing that first multiplication, and then we have to multiply this to x squared. Okay, now look, technically there's a 1 out in front. So I mean, technically you're doing negative 3 times positive 1, which is negative 3, and then you're doing x to the second times x to the second, which you add the powers and you get x to the fourth, okay? And then you keep distributing. Negative 3x squared times negative 6x. Well, first of all, negative 3 times negative 6, that's positive 18. I'm running out of room here. That's positive 18. And then when you do x to the second times x, which is technically x to the first, you get x to the third. And then when you do negative 3x squared times negative 7, you get positive 21. And then x squared, there's nothing, but so you just have an x squared. Okay, so this is the answer after distributing the negative 3x squared. Likewise, up here, we're going to have to distribute. So Jack, talk us through when we distribute the 4x to all 3 of these terms. What are we going to get here, Jack?
Oh, I didn't do it yet.
That's okay. And no rush, just let's do it live. Like, let's talk us through it like I would, you know what I mean?
4x to the third
Perfect.
minus 20x to the second.
Awesome. Because remember, people, x times x is x to the second.
Plus 32x.
Perfect. Nice job. Okay, hopefully everyone yep. I guess what I'm most worried about, but Jack got that right, x times x squared is x cubed, or x to the third. X times x is x to the second. Yeah, that's that one. Okay. Aaron, let's see if you can do this. So in this next, and again, no rush, just you can go through it slow like I would. But we're going to be distributing the x to the third to all 4 of those terms. So Aaron, take it away if you can.
4x to the 7th.
Awesome so far. And then x to the third times x to the second would be what?
X to the 5th.
Perfect. And then x to the third times negative 5x.
Negative 5x to the 3rd.
So close. Remember. So, hey, and again, no one should feel too bad. Like, this is what a lot of people, like I was expecting this sort of. X to the third times x. Remember, technically, that's like x to the first. So it's going to be minus 5x to the 4th. Okay? So yeah, x to the third times x is actually x to the 4th power. Okay? And then you're just plus 1. So think about this. When you do x to the third times 1, just 1, that's when it's x to the third. Because that's just the number 1. And last one, I don't know. Connor, really quick, how about this last example?
You just don't know how to explain this. It's just simple distributing.
Yeah, well, yeah. That obviously, I guess. Hopefully, obviously. What would you get when you distribute the negative 2x to all three of these terms?
Negative 2x to the fourth plus negative 18x to the second plus. I forgot to do that one. Negative 12x. Or 12x, sorry.
Yeah, because it'll be like a negative times a negative. There you go. That's right, people. That's it. So again, just one more quick reminder for, I know I feel like a broken record here, but man, like, getting a solid passing grade is not just about, knowing the math, but you got to be like hitting your due dates and stuff like that. So, and hey, if you don't want me to be a broken record, then let's have everyone start turning stuff in on time a little better. But no, what I really wanted to remind you of is like this quiz, which is technically due tonight, even though like I would think more than just 3 people would have done it by now, since like, because these are like not that long and complicated, you know what I mean? But yeah, like, please, if you have not done this, obviously you want to do everything that you have not done yet that would be late, but you definitely don't want this to be late. So make this a priority, and then other things that are technically late or whatever, and then you'll have your homework to do, which I don't think there's any surprises. Maybe like number 30. We didn't do an example exactly like 30 or 31 or 32, but I bet you guys can figure it out. Maybe on Wednesday we'll follow up on that or something, but let me know if you have any trouble. So if you have any questions, then stick around for a second. Jesselyn, if you have time to stick around for a minute, stick around for a minute, Jesselyn, but anyone else that's good to go, I'll see you on Wednesday.